Hi everyone, welcome back again on Big O Part 8 of this playlist. So today we will be going through another question in this series. And before we go on to this question, let's briefly talk about what we have discussed so far. So in earlier parts of Big O Notation playlist, we started with what Big O Notation is all about, what is its significance, where it is used, and then we looked at some related terminologies like big O, big omega, and big theta, wherein we understood that uh, big O basically describes the upper bound on the runtime, big omega describes lower bound on the runtime, and big theta describes the tightest bound on the runtime. And we from that we also learned that whenever we are determining the complexity of given algorithm, then we should always look for the tightest bound on the runtime. Now, in later parts, we also learned about time complexity and space complexity, which are two parallel concepts to analyze the uh, time, how much a given algorithm will take, as well as how much space or memory it is going to occupy when the program will run. And with that, we looked at few examples and few common patterns where we found like the complexity can be order of one, which is a constant time complexity. Then we looked at some other examples of having order of n complexity or order of log n or 2 raised to the power n, right? We also looked at some explanation about log n complexity as well, uh, recursive code complexities, and then some lights on amortized time. For example, array list, wherein it grows dynamically, and we looked at inserting n elements in array list. The amortized complexity comes as order of one. Then we also looked at the ordering or basically how one complexity performs better than the other. For example, we noticed that log n performs better than order of n. We looked at some examples like binary search where we found that if we are given an array and we are also given a number to find in that array. So if we go with the example of with the algorithm of linear search, then it's going to take order of n time. But if we go with binary search, provided the given array is sorted, then it's going to take log n time, because each time we will just shrink the range to one half of the array. So we looked at how this complexity uh, comes down to log n by some simple maths. And then we also looked at recursive examples wherein in every call we were calling uh, uh, one number less of the given number two times, wherein the complexity came as 2 raised to the power n. So I think it is a really useful and interesting concept to learn. And as well, this is very important from competitive exams point of view. I think I would highly recommend to uh, go through all the parts which I have covered previously in this series. And as well, anytime you have any question or you feel like something is I haven't explained very well, then please drop it in the comments and I will definitely try my best to recapture it again. And as well, I think I speak very slowly. So if you want to listen all the parts in the series with 2x speed, then that should be okay too. So with that, let's get started on this problem. So here we are given this program and we have to determine its runtime. So I have taken actually the ribbon bar at the top because I want to explain how we should approach any given problem to find its runtime. So I will be erasing some things. That's why I kept it like this, ribbon bar open. Yeah. So now what we are doing is in this method, I will just maybe uh, see. Okay, let me just think. Okay, so we are given this array, and in this, what we are doing is we basically let me just see if I can write it properly over here. So we are given this array, and then what we are doing in this is we have this for loop. This for loop is basically goes through all the elements starting with index 0 till end, as we have see here array dot length, right? And then I plus plus. So it means that my outer for loop will, so if I have 1, I have 2, 3, 4, and 5, right? Let's say this is my array. And I have 0, 1, 2, 3, 4, right? So I starts with 0, then it will go to 1, then 2, then 3, then 4, right? So this will go, this will traverse through the entire array, this first outer for loop, right? And then what we have is we have this curly brace. So whatever we are doing is um, inside this for loop for each index. So when we are at 0, let's say when I is 0, right? Then what we are doing is we are going, we have one more for loop in which we are going with j's I plus 1. And also keep in mind that we are referring to the same array here, right? So it means j starts from the next value of I. So it means j will go from 1 to 4, right? So if I write it down here, when I is 0, then j goes from 1 to 4 till the end. When I is 1, then j goes from, sorry, 2 to 4. When I is 2, then j is goes from 3 to 4. And when I is 3, then j goes from 4 till 4 actually, because it cannot go outside. And when I is 4, then j will try to go from 5, but it will not go. So it will not run. So overall, like if we want to determine its complexity, so let's say, so in this case, what we are doing is, so basically, if you see here, right? So first time, let's say if I have n elements in this array, right? In the top array, we have n elements. So what I am doing is, if you carefully look at this, so very first time when this inner for loop runs, so it goes to, uh, we can say like, uh, all the elements, right? Because when I is 0, so j will go from 2 to 5, right? It will go, so its index will move from 1 till 4, right? So it means we are covering, so how many times it's going? So in first time, so if in my array I have n elements, so in first iteration of j, so we can say it goes to n minus 1, right? So if you see here, when I is 0, then j goes from index 1 to 4 till 4, right? So overall going uh, it's going 4 times, one less than the total amount. So n is my 5, but I am going till 4. So in the first time, I am printing this sysout thing 4 times, n minus 1 times. Then next time, so basically, if you remember from previous examples, so runtime is like how many times I am printing this sysout thing, right? So that is my runtime. So if my array has n length, then first time it will, this is out statement will be printed n minus 1 time. Then next time when, if you look at this example, so next time when I is 1, then j will go from 2 to 4, right? So it means it will go n minus 2 times, right? First time it went n minus 1 times, second time it went n minus 2 times. Like that, it will go to n minus 3 times. And likewise, if you see here at the end, when my I is, let's say, at 3, then it will be just one time. It will be printed, right? It will just go J start with 4 and that's it. So overall, what I am saying is, so overall, how many times this sysout statement will be printed is, we can calculate like this. So n minus 1 plus n minus 2 plus n minus 3 plus n minus 4 and so on till 1. Now if you know the uh, maths from our time, so one way to calculate it is, so if we have n natural numbers, and you can simply assume that it is going like this: n plus n minus 1 plus n minus 2 plus n minus 3 and so on till 1, right? So we have to sum this up. That's how we will know how many steps or how many times sysout is getting printed, right? So whatever we are doing here is, we are saying in this example it's 4 times, then it's 3 times, then it's 2 times, then it's 1 time. So that is my total time sysout will be printed on the console. So likewise, if there are n elements, so it will be printed n plus n minus 1 plus n minus 2 plus n minus 3 till 1. So we have to sum this up. And we know the sum of n natural numbers is n minus 1 divided by 2, something like that, because it is actually a series, arithmetic progression series, right? So maybe if I go to next slide here, I can type it, I can write it. So this is my, if I have a series like this, 1 plus 2 plus 3 plus 4 plus 5 plus so on plus n, right? So how I will find the sum? Sum is in GP series, in AP series, arithmetic progression is A plus, um, I do not fully remember it, but A plus n minus 1 into d, something like that, right? Oh, sorry, I think it's n by 2, 2a plus n minus 1 into d. So it is my n by 2, 2 plus n minus 1. So n by 2, n plus 1, right? Yeah. So I think this is what we are doing is right. So, uh, so if I have to find the sum of n numbers, n natural numbers, then this is a kind of arithmetic progression series in which the sum is this one, n by 2, 2a plus n minus 1 into d. And this is going to be by n by 2, where a is my first term, right? So this is my first term, and this is the difference between two terms. So first term is 1 here, right? And the difference is 1, then 2, then 3, 1. So d a is 1 and d is 1, 2. So if we calculate it, so it will come as n by 2, n plus 1, right? So what it will, you will discover is n square plus n divided by 2. So if now you want to basically drop the constants, then it's going to be n square plus n, and eventually it will be n square, right? So order of n square will be our complexity. So what we have done here is we were given one algorithm. So what we did is this, we were given one array. So we can see in the outer for loop it goes from 0 till end, and then inner for loop goes from again kind of I plus 1 till end. So it means first time it will run n minus 1 times, then second time it will run n minus 2 times, then third time it will run n minus 3 times, and at the very end it will just run once when the I will reach at the end almost. So the total times this sys out will be printed is the sum of all the executions, right? So which will be like n plus n minus 1 plus n minus 2 plus n minus 3 up to 1. And if we think it from a reverse direction, so it is the sum of n natural numbers where first number is 1 and the difference between the first and second is constant, which is 1. So it comes to nn plus 1 by 2. I will just correct it over here, right? So eventually it will be order of n square. I hope it was clear how we have found the complexity here as order of n square. I think you can listen to this. If you have any question, please feel free to drop in the comments and I will try my best to answer this. And with that, happy learning. Thank you.